What we're looking at here is a little bit of magic. This should actually not be happening in reference to classical physics in regard to what the researchers believe. Now, this mathematical formula is a formula which you could slide up and down depending on the circumference, or I should say the radius, of, let's say in this case, envelope respiratory viruses. Now, there's the key, the radius. This is the part that makes the story interesting. These viruses themselves, which are circular, really do not have a defense against acoustic resonance. Again, I'm going to reiterate, it's not cavitation. So this could even be postulated to work for certain things like bloodborne viruses, let's for example, hepatitis B and C, HIV-1, Zika. So we're looking at 120 nanometers, hepatitis B, C, 40, 50 nanometers, Zika virus, again, about 50 nanometers. So what you're looking at basically is this formula can be scaled by using equipment that already exists in the hospitals, especially the equipment in regard to acoustics, ultrasound, so on and so forth. So without further ado, keep this formula in mind for the future in case of a zombie apocalypse, because you know what equipment in the hospital is going to be the greatest value to you. So let's get right into the research as follows. Scientists use ultrasound to destroy, we'll just say enveloped respiratory viruses, so I don't have any problems with sensors, without damaging human cells. Again, acoustic resonance, not cavitation. So kind of like a surgical strike. Researchers at the University of Sao Paulo in Brazil have discovered that high-frequency ultrasound waves similar to those used in medical exams can eliminate viruses. In this study, quoting, "We proved that the energy of sound waves causes morphological changes in viral particles until they explode, a phenomenon comparable to what happens with popcorn. By degrading the structure of the pathogen, the protective membrane of the virus, called the envelope respiratory virus, bursts and deforms, preventing the virus from invading human cells." To proceed forward, do the public released research. It's the geometry. The discovery surprised the researchers because it contradicts classical physics theories, as the wavelength of ultrasound is much longer than the size of the virus. In theory, the difference in size would prevent interaction, but au contraire. This phenomenon is entirely geometric. Spherical particles, such as many envelope viruses, absorb ultrasound waves energy more effectively. It's the accumulation of energy inside the particle that causes changes in the structure of the viral envelope until it ruptures. Therefore, if viruses were triangular or square, they wouldn't undergo the same popcorn effect of acoustic resonance, quoting the researcher. They also point out that since the process depends strictly on the shape of the viral particle, the music of the spheres, in this case, kind of like acid rock to a classical composition of these particular spheres. He points out that the viral particles and not the genetic mutations, meaning it can't mutate its way out of this like it would with a vaccine or some other sort of antiviral. Variants such as those observed during the pandemic, Omicron and Delta, for example, do not affect the effectiveness of this technique because it can't escape the shape that they are. The result is a selective and safe mechanism, since only the virus absorbs the energy and is destabilized, posing no risk to human cells, quote unquote. Albeit, keep in mind, this is an in vitro study, meaning not on a living organism as of yet, but still, as we move forward, you know it's going to happen. Now here we go. Let's go to the conclusion. The ability of the acoustic waves to penetrate tissues without invasive procedures positions ultrasound as a promising candidate for targeting viral reservoirs in anatomically challenging sites, including the lungs and central nervous system itself. Because it's the acoustics, the sound waves travel through it, and this particular resonance, the 7.5, permeates liquids fairly easily. All right, so now let's get into some of the infographics to elucidate what you and I just observed in looking at the public study and the full study itself, parts of it. All right, to proceed as forward, the geometric vulnerability, exploring the math of the sphere. So looking at 7.5 megahertz, some of you go, oh, 7.83, that's Schumann resonance. No, that's hertz, this is megahertz, a million cycles per second as opposed to 7.83. Translation, every object has a frequency that makes it shake. Because respiratory viruses are perfectly round, bubbles of fat measuring about 100 nanometers wide, a 7.5 megahertz sound wave makes them shake so violently they break. To proceed forward, it gets even more fascinating. The cumulative stress, the time course, the viral spectrum, boom. Now check this out. Look how fast. Now again, this is not in human tissue. I mean, per se, has to be tested in living organisms, but right now, what we see in the lab is quite fascinating. 1 minute. Now keep in mind, in order to basically get total dominance, you want to go 30 minutes or longer, depending on what the scenario is. But 1 minute, look how fast that affects. Boom! Incredibly fast. And again, it gives an explanation and a translation of some of the envelope viruses, which we've discussed before. All right, and here we go. Boom, boom, boom. The beauty of resonance, a universal physical antiviral. And that is an understatement. Immune to mutation, because it is the shape. Again, I'm reiterating over and over again, it is the shape that is the weakness. Nothing else except the shape and elasticity, density, and so on and so forth, where you could scale that formula up and down depending on what it is. The zero tissue damage. We're now looking at cavitation. So that's what makes it beautiful. And the volumetric reach. Unlike ultraviolet light, which I love as well, which only sterilizes the surface, it can visually touch acoustic waves travel seamlessly through fluids and soft tissue. This allows theoretical targeting of deep viral reservoirs, including the lungs and the organs. Again, to reiterate once again, ultrasound does not care about disguises. So the virus may attempt to mutate to get away, but however, though, doesn't make a difference. I see you. That's all that matters. It only cares about the size of the virus. It's universal, a safe, deep penetrating way to destroy pathogens. Again, according to the research, and here we go, the target list of expanding the acoustic arsenal. There you have a few of the concerns, some of them bloodborne, some of them seasonal threats, so on and so forth. That's for future research. Again, I want to interject publisher bias, but that's why that formula is important, and the discovery is even more important as we move forward. All right, and again, save this for the data part. All right, so here we go. So let's look at now. That is the basics. Now we go more in depth. So please forgive me if this seems a little more technical than we already have elucidated. You say that word over and over again. Talk about reiteration. Ultrasound is a mechanical antiviral. Again, 7.5 megahertz was the peak resonant disruption. At least the models that are utilized right there. You can see as far as the Wuhan, the Gamma, Delta, and H1N1. All right. And then as we proceed forward, the frequency-dependent activation. Again, the size, the elasticity, the Poisson variables, and so on and so forth, looked at before. 7.5 seems to be the magic number. Less, not as effective. More, not as effective either. That is the magic, I want to say magic ratio, but that's 5. The methodological rigor, here we are. We're looking at a 0.01. Pretty nice strengths, limitations, obviously being in vitro, but we could change that as time moves forward. What exactly is breaking? All right, the lipid envelope, boom. The acoustics can't handle it. The circular shape and the spherical. I want to say music of the spheres now because I got the second in my head. All right, the spike protein is the face, the nuclear proteins, the popcorn effect, and the host cells, which could be you, I, or anybody else, remain intact. All right, the acoustic therapy, repurposing diagnostic ultrasound equipment. Again, zombie apocalypse stuff, or whatever it comes down to be, some sort of something that requires immediate attention. I want to say national emergency, but I don't want to send that out there. But however, though, there you look at the targeted load reduction, the blood and plasma sepsis, and the efficacy of drug efficacy as well. Medical imaging transducers, 3 to 20 megahertz, already deployed in hospitals, can theoretically be repurposed to deliver this highly specific localized mechanical disruption to envelope viruses. Translated the physics into clinical deployment. The linear array, again, 7.5, good resonance at 100 nanometers. We're proud about it is, think of it this way. We're not even caring about the name of the virus. Now, elasticity and density matter as well, but we're not looking at the name. We're looking at the shape. Is it 100 nanometers? Is it a sphere? Boom. I don't care what you call it. There it goes. 7.5. Throw it in the system and see what happens. Controlling basically the mechanical index. You don't want cavitation. All my submariners out there. Submariner class 101. Cavitation, first thing you learn. And the cumulative disruption. Again, 30 minutes. 1 minute, you have a great drop. But 30 minutes seems to be a little bit safer in the translational effect. Mathematical formula, once again, important. Showed it once in the beginning, showed it here as well. It may be something you want to write down. You never know. All right, the cavitation myth. Again, a lot of people are going to go, all right, well, it's cavitation. It's disinfect equipment. Again, Acoustic resonance, not cavitation. The scalpel, the resonance. I want to point that out one more time just so you could see that basically difference between the two. This should be rendered in 4K, the video, so you can freeze it and read through. For the sanctity of your time, I move forward. The acoustic interrogation matrix, that sounds so bad, but there you are as far as basically the protocols, the blueprint, and the protocol to bring into living organisms. Looking at $2.5 million. You think about it, we spend money on a lot of erroneous stuff. Something that has such incredible impact, $2.5 million, is really, it should be a no-brainer. But let's see what happens as the future proceeds. Application and utility. I like the wine glass effect. Boom, shatters. The variant proof and the deep tissue access. Unlike UV light, to reiterate, which only works on the surface, ultrasound waves penetrate fluids and soft tissues. This opens the door again to therapies to clear viral reservoirs from lungs and blood without pharmaceutical toxicity. Again, not any publisher bias, but that seems pretty promising. The glossary of terms, again, cavitation, the mechanical index, the lighting scattering, that's how they measure the breakup of the virus envelopes per se, and so on and so forth, and lipid envelope. Well, that's pretty self-explanatory. But again, boom, want to do the formula one more time? There you have it. So you get it right there, and mechanical index, you don't want cavitation, you want acoustic resonance. You just scale this formula up and down and see what happens. Again, future testing, albeit. So what an incredible breakthrough that most people are never going to hear about. But however, though, I do the video because it puts it out there. They did the research, so I'm basically like a tuning fork resonating what they discovered to you. And however, though, let's see where this goes from here. Again, gratitude for the incredible breakthrough research, which it is, because it was an assumption that it shouldn't work. But you know what? They said, what the heck, let's try and see what happens. And it worked. And that's why assumptions may be a little bit too much of a bias or confounding factor that can impede great breakthroughs as such. Again, gratitude to the researchers. I am humbled you watch. The infographics, I always keep my clinicalnews.org site just in case, because there's a lot I still leave out, but you can review it on your own if you like as well, outside of the video itself. Gratitude, thank you, and look forward to see what you and I both discover next week. Catch you all next time. See you then. Bye.